Hey everyone, welcome to the podcast. I've got with me Cody from Solidigm, who actually is part of the team that did something pretty crazy at GTC. They decided that cold plates and SSDs need to go together, and so they ran a demo showing what can be done if we liquid cool SSDs with these high-end, presumably AI or GPU servers. Cody, what is going on over there at Solidigm, and what makes you guys think that liquid cooling SSDs is an important idea?
Hi, Brian. I wanted to first thank you for inviting me here on the podcast, and excited to be able to talk a little bit about our, innovative solutions that we've come up over here with over here at Solidigm. And yeah, so I think that as we've seen the data center market evolve from strictly air cooled to a hybrid cooled solution, and now looking at the market toying with these fully liquid cooled GPU servers or high performance AI servers. I think that's where we saw the opportunity to introduce a innovative product that allows us to sort of push the market forward, if you will, in terms of, hey, how do we liquid cool other devices besides these high powered CPUs or GPUs at the platform level?
Yeah, I mean, obviously the liquid movement, whether it's directed chip, immersion, which we can talk about a little bit too, because we did a couple weeks ago take a bunch of your E1S drives and dunk them in Castrol data center fluid as part of a video we did with Doug. I don't know if you got a chance to catch that one yet, but the vision of hot swapping an SSD and having to dump the oil out is pretty humorous. But yeah, all these liquid cooling things are happening, and most of us think about it at the chip level, either CPU or GPU. But I think the trend that you're talking about, and surely was a hot topic at GTC, is can we liquid cool the entire system? Lenovo's
Right.
done that for a couple years with their Neptune systems, where they put copper on everything, the DRAM. They've even done it with hard drives or SSDs and these little blade servers.
Mhm.
What you guys were showing was a larger block, water block, and
Mhm.
SSDs, and getting after your piece of that puzzle. How do we get smarter with cooling storage, right?
Right. And so what our solution was is, we wanted to maintain the key functionalities of SSD. You talk about things like hot-swappability or serviceability. I think that's a key aspect from what I've seen. There's oftentimes, you know, more cumbersome solution or something that requires like the like a special tooling to replace like the cold plate, or requires some downtime at the server. And so what we wanted to demonstrate is that we're able to take our normal SSD, we're able to liquid cool it with a carefully designed cold plate mechanism, and
Mhm.
we're able to extract the heat from just one side of the SSD, even at these higher Gen 5 speeds.
So this is interesting, and I probably should have started this with you're a technical guy. You're not a product marketing guy, or maybe you're a
Yes.
hybrid. What is your function anyway over there?
Yeah, so I'm a thermomechanical design engineer, and
Perfect.
so
So
I'm
this is one of the rare cases where a company is brave enough to let one of the nerds out of the lab to talk to a media outlet. So this is perfect though, because we could really get into it
yeah.
if it was just a regular old run of the mill marketing folks. They sometimes don't have the technical chops. So you'll know
Mm.
everything about this, which is fantastic. So when we think about cold plates, traditionally, pretty much with a conductor in between, they sit on the chip, and as the chip off puts out its heat, it runs a liquid loop through there, and then
Right.
replaces that with cold water, or water water mixed in with some chemicals to move that off somewhere else to cool it
Mm.
back down to bring it back through. And those designs have been largely driven by uh, vendors like Cool IT that are responding to the needs from NVIDIA, AMD, Intel, et cetera,
Mm.
Childyne. I mean, there's a number of vendors out there with really innovative
Right.
cold plates. But I haven't seen that same cold plate vendor crew go after storage. And I guess it's because they haven't felt like they really needed to, or weren't asked to, which is kind of where you stepped in. And with you specifically understanding the thermals of especially Gen 5, and it's not just Gen 5, this problem gets worse as we go to Gen 6, Gen 7, and beyond, right?
Right.
You guys stepped in and really understood the heat profile of an SSD, and that's where we ended up with this demo.
Exactly. And I think that, we've had some conversations with, uh, some of our customers asking about, we see liquid cooling happening at the data center. What are your thoughts on SSDs? Do you think this is going to come forward to the drive bay? And some of the conversations, we're like, we're not quite sure. But I think that what our team saw is that with these new high performance data center servers that are coming online, we were just thinking it's only going to be a matter of time before they decide, hey, we don't have the space for these fans. We have to re-architect the system
Yep.
in order to enable 100% liquid cooling across the board. And so what my team and I did is we came up with a sort of cold plate reference design that would say that, okay, as we looking forward, we see these systems potentially going here to 100% liquid cooled. How can we help the market move things along? And so what we did is we came up with um, you know, a, a unique mechanism that helps to facilitate heat transfer between the SSD and the fluid, and we're able to sort of maintain these key features that we've seen in the data center up to this point. So I think it was just us sort of having this, hey, what's coming next mindset, sort of an innovative mindset along those lines, and trying to figure out how do we help enable this, even though we haven't quite seen it yet in the market. And but we want to make sure that these sort of things are unblocked so that way we don't slow down the innovation happening.
Well, I mean, I think it's a great technology halo for you guys. I mean, obviously, we've talked about Solidigm a ton over the years, from the capacity leadership in QLC, which remains with the 122 terabyte drives, but also Gen 5, right? You have very fast drives for the latest enterprise workloads. And while we all get wrapped up in AI for good reasons, there's still, I don't know, like these database things that still happen in the enterprise that
That's right.
organizations want to go more quickly. And, there's other things that we
Mhm.
sometimes don't talk about as much anymore in the AI washing of all IT marketing. Um, but yeah, the SSD itself in your demo, let's tear into that a little bit. You're showing
Okay.
E1S drives, which are the kind of the standard. If I'm looking at like the NVL72 racks from NVIDIA, they went to E1S, and those very popular with the hyperscalers, a little less on mainstream enterprise, but also liquid cooling's a couple steps behind in that group anyway. So E1S makes sense just from an adoption standpoint. But if we think about what you've got there is a pretty slim SSD. If you take the heatsink off, it's what, a little under 6 mil. Is that right? Just
It's
the
the
board?
9.5 millimeter form
Okay.
factor.
Okay. And then we've got the heatsink wrapped around it, but you've got NAND on both sides. You've got
Hmm.
DRAM and the controller on one side.
Hmm.
And I guess those two components get the warmest. So as you think about where you need to apply cooling, is it to both sides? Do I need to sandwich that drive in between two cold plates?
So what makes the solution unique that we came up with is we're only contacting the SSD on a single side of the drive, and that enables us to pack in more storage in that same footprint. So if there was a dual-sided cold plate solution, you're talking about having a 4 or 5 millimeter cold plate on either side of the SSD. And then that is just taking up space within the server. So the way that we've designed it, only need a single side contact, where we've optimized the thermal topology of the product to make sure that we're taking full advantage of the cold plate contact. And we're sort of taking advantage of that space that would normally be occupied by the 15 millimeter version of the E1S, that thin structure. We're
Right.
taking that space that was generally occupied by that thin structure, and we're replacing it with a cold plate. So at the platform level, I think about E1S 15 millimeter SSD. We're just taking that same drive bay, we're converting it from a 15 millimeter SSD air cooled to a 9.5 millimeter SSD liquid cooled. And so talking about not losing that sort of drive dense number of drives and that platform for designed for a 15 millimeter SSD.
Yeah, that's one of the fun things with the E1S spec is that there's like 6 different Z heights for these things, ranging from
Yes.
no heat sink at all to I think they go up to 25, right? I think that was a popular one
Yes.
at Meta
Yeah.
for some reason. But really, what we're talking about is not changing the PCB. You're really changing the way the heat gets transferred in your heatsink, then to the cold plate. Is there any change at all to the PCB, or is this still just a garden variety PS1010 Gen 5 drive?
So we did do some internal optimization of our drive to take full advantage of that cold plate connection. And since we're, limited on, on the heat transfer we're getting on the opposite the cold plate contact, we did have to do some unique things within the SSD to make sure that we're thermally balanced in our design.
So, what does that do then, for the drive in terms of performance? Because we know that if the drive gets too hot, it'll throttle to go into self-preservation mode. We've done that sometimes by accident, sometimes on purpose in our labs. I know
Mhm.
you guys, I've been in your labs at Rancho Cordova. I've seen the thermal room there where you guys will often overheat things for funsies just to test those outer edges. But in a design like this, is your goal to maintain parity with air cooling and the full 15 mil heat sink, or is this better than air cooling with that big sink when you look at what you can do with liquid direct to chip?
So it's better in the sense that what we've done is we have a solution here that as we scale the power, we're able to maintain no throttle condition on the drive. And so thinking forward, like I've been talking about, as we think forward to maybe these higher power Gen 6, you know, products, or ramping up the power on a Gen 5 product, liquid cooling sort of unlocks that next level that you'd be limited by the thermal performance. And so say like a 15 millimeter SSD, well, this allows us to go beyond that general power limit for 15 millimeter, and it sort of unlocks that next level of performance. Like, hey, if we wanted to drive the performance of our SSD up further, that gives us an opportunity in this same form factor to explore opportunities where we could increase that power performance to the drive and not necessarily break things thermally.
Yeah, it's interesting because we did some work around power states at the end of last year for OCP. We were using your drives, actually, the QLC drives, and looking at what happens to performance if I'm really concerned about 20 or 30 or 40 drives in a single box. And
Mhm.
instead of running at full power, which is what, 25 watts, yeah?
Yeah.
If, okay. And if I trim that back and I want to save 10 watts a drive, 8, 12, 15 a drive, because that adds up. That's it sounds incremental, but times 30 or 24 is a
Yeah.
huge number in terms of what you can do from a power managing the power envelope. But if I take it down, my reads remain pretty good, but my writes will eventually suffer as I trim the power back to that drive. But talking about Gen 6, you go from 25 watts to what's the target there? 35 or something, or is it higher?
You know, I don't know exactly what the target power is off the top of my head, but I
It's
do
it's
know
higher
that,
than it's higher than Gen 5 though,
yeah,
significantly.
yeah. And I do
Yeah,
know
and
that,
so
as an industry, like I think that there is some opportunities where we talk about like direct attached storage. How do we drive up that power envelope for specific applications? And so I think that talking about higher power, maybe the 30, 35, 40 watt, I think that there is some limitations with that E1S connector specifically. And so I think that that obviously would come into the equation as you think about these higher powered solutions.
yeah, I mean, the storage world's so wild right now. We went from this U.2 form factor that feels like it's been around forever. It's not that old when you compare it to SATA and SAS, of course. But my goodness, now with all of the form factors in the EDSFF world, it's wild, from the early Intel ruler days to the short, the long, the E3, the double thickness E3. I mean, it's pretty crazy. And I know you guys can build anything, but the trouble with all these form factors is, I suspect, is that your customers are all asking for different things, which can
Yeah.
be could be challenging. But as you hone in on this liquid cooling thing, I mean, it's really around these AI systems that are the taking the lead there. And
Mhm.
so you talked a little bit about what you had to do with the drive. What's the IP specifically, or did you guys put a patent or something around this? Are you open sourcing this technology? Kind of what's the Solidym's goal with this demo?
Um, so the Solidigm's goal, I believe, at a high level, and being the technical guy that I am, I don't get too much in the weeds as far as um, the IP and such is concerned. But our goal is that we would help to enable server OEMs and ODMs with this technology to help sort of with their liquid cooling adoption. And so what we see is, having a reference design, and these companies come to us. We have our liquid cooling reference design. We have some IP around that, and then we're partnering together with them to enable things at their platform level. So I see it more as a partnership. Here we have this technology. We want to partner with you to see what we and sell you our drive to see what we can do as far as enabling these liquid cooling solutions, in their various platforms.
Well, the march towards liquid cooling is demanding all components to be aware of this. And we saw it. I was at Data Center World in DC recently, and there were more CDU vendors there than I knew existed. So we did a podcast with Cool IT when we were there, and it did not dawn on me at the time that I should have probed into the cold plates and storage there. But they can make whatever the the server guys want. All it is two more runs off a manifold that's already in the system to run it to a
Yep.
cold plate. And then if you guys as Solidigm are making SSDs that are tuned for cold plates, then it's a nice little marriage to put those together. I suspect that the rest of your competitors will have to do something there too, as they think about what are the needs for a liquid cooled system where I'm only going to get the cooling on one side. So, like what you were talking about, make the side that's only in contact with the case has got to be a little more efficient, so that can wrap around and then eventually get to the cold plate. Um, but as we saw too with the immersion, I know immersion's not as popular in the United States as it is elsewhere, but we've seen some massive deployments. Doug, for instance, they've got 440 plus immersion tanks in their Houston data center, which is totally wild. And as we talk to these guys, it started out with just taking a server off the shelf, dunking it in. What do you
Yeah.
learn? You learn the cables get brittle and crack. You learn all the labels fall off and sink to the bottom and start to corrupt your fluid, which is interesting. And you learn a bunch of other things about the thermodynamics of how that oil moves through the system, what you need to remove, what you need to enhance to make that happen. And I think when we were there with Alan, he was looking at it from an engineer's perspective, thinking, "My gosh, okay, so if we're going to dunk these things in oil, we can kind of rewrite we could theoretically rewrite the rules on how we treat flash as part of that. I mean, it doesn't have to be delivered the same way as we deliver it today. I mean, there's just so much going on there. As a thermal guy, it must be exciting on your side of the house to. Sounds more exciting than signal integrity to me, but I don't know what does it look like in your labs.
Yeah. So I mean, I think it's an exciting time to be a thermal engineer for sure. I think that, for the longest time you kind of saw the market, air cool, how do we optimize air cool? And then I just feel like there's been this jump in it. I think it's been about the last 3 years here where we've just seen this huge acceleration in terms of direct liquid cooling and immersion, and it's been fascinating to explore these different details and different trade-offs of different types of cooling technology. But as Solidigm, we want to make sure that our products can fit into all these different spaces. We're optimizing for air cooling, for immersion cooling, for direct liquid cooling. We want to partner with customers, figure out their specific needs and what we can engineer or how we can engineer our solutions to ensure that our drives are performant in these very strenuous environments. I saw that deployment that Doug had there. I think it was like in a parking lot, right? Like a
Yeah, yeah.
container in a parking lot.
It wasn't just like a Popeyes. It was like next to a data center. I mean, you make it sound like they just showed up.
Yeah, so I mean, I remember
Wawa or
Alan
something like
mentioning,
this.
yeah, Alan mentioning something like that. Yeah, I'm just like going to a parking lot in the middle of, some residential area, and I was like, all right. So, we think about these different applications, and us as all, I want to make sure that we are, we got our hands in these different markets to see, how do we help enable our customers. And, talking about our lab specifically, we've definitely looked into these different cooling technologies, from immersion to direct liquid cooling to air cooling. And so we're definitely exploring, what opportunities are there and how do we tune our drives to make sure that we're meeting our customers' needs.
Yeah, I mean, yes, and it makes a lot of sense. One of the things that we've seen and heard anecdotally from organizations that have adopted liquid at a high level, either directed chip or immersion. Specifically with immersion, I've got a little more data on it, but the failure rates seem to go down tremendously. And I know Flash already has a pretty low AFR, across the industry, not just you, but if we look at all NAND, pretty low, especially compared to hard drives, which were higher, more moving pieces, obviously, and complexity from an engineering standpoint in those designs. But what do you see, or what do you expect to see? Because it may be a little too early for your lab. Do you think that as you go to more liquid cooling of any variety with flash, do you think there'll be a positive side effect on SSD AFRs, going down because of the better cooling?
I I'm not really sure, so I can't really comment on that. Um, yeah, that's not really something that I personally have looked into much. So yeah,
Okay.
I'm not certain.
Well, I just think if we make the logical connection that better cooling drives stay cooler, one less thing, because heat is the enemy, an enemy
Right.
of an SSD. So certainly performance should benefit. I'll think the AFR should
Yeah.
benefit. I guess we'll see as more of these get out there.
Yeah, and I think one thing that's powerful about liquid cooling is you're able to be a little bit more selective in what you do as a thermal engineer at the platform level. So, holding drives at more of a steady temperature, understanding flow and pressure drop at a system level to where you can peel off a certain liter per minute to keep your drive at a certain temperature range. So I think that some of those variables that existed with air cooling don't exist as much. I mean, there's still plenty of variables at a system level you need to consider, but I think that there is a opportunity there to sort of tune the platform in a way to keep your SSDs at a at a at a performance and a temperature range that would allow maybe for some better life, like you're suggesting there. But yeah, I could definitely see that you have a little bit more knobs to turn where you're not necessarily hurting a downstream CPU or GPU because you're increasing the fin density or something on your SSD.
Yeah, for sure. And of course, when we take the fans out of these systems, tremendous power savings there, upwards
Mm,
of 25, 30%, based on the numbers we're seeing. And they get a lot quieter too. So these AI data
that's
centers that
right.
are fully liquid cooled are it's very bizarre when you go in and hear the whooshing and whirring more than the screeching of the fans. So go back to GTC. You guys were showing off this demo. You had 4 or 5 drives set up in a little E1S backplane with a liquid loop going. This is obviously not production. This is proof of concept as you work through these logistics. What sort of feedback were you getting at the event or afterwards? Because I imagine most of the people coming by were like, what is this? This seems bizarre. What other than disbelief, what were there other takeaways that you either expected or didn't?
Yeah, I did think it was funny. A lot of people would stop by and were like, "What is going on?" And so a lot of it was just a kind of explaining what was happening in general. And for our demo specifically, like you said, we had our E1S. We were demonstrating the hot swappability. We were demonstrating our drives. They were running Gen5 speeds. We were able to hot swap, still maintain that key feature there, and then we were able to hold the SSDs at a consistent temperature below throttle. So we were kind of focused on that part of it, and so sort of walking people through that, kind of showing off our technology to them that was fun, something I hadn't experienced before, and so that was neat. I'd say that overall the reaction, like afterwards, some of the things that I didn't expect. There was quite a few, articles and things of people popping up around this. I didn't really expect that as much, but it was neat to kind of see that. Like, I think we've gotten the industry thinking a little bit, and
Yeah.
we've definitely, I think, people are starting to scratch their heads a little bit. Like maybe there is something here that we can help drive towards 100% liquid cooling, and maybe there is some benefits at a data center level that haven't quite considered to this point because we haven't seen this sort of technology. And so some of those reactions, I guess, I don't want to ramble, but
No,
the
I think it's fun, and you encapsulated it. The what the heck are you crazy guys doing? I think would be the number one. And then, as you said, as it soaks in, they're like, ah, okay, makes sense. And I think I don't want to put you in a position to speculate, so I shall. On the GB300, as we look at these platforms, everyone we've seen is all liquid cooled, and so most of them are missing the drive bank if you look closely. But I think it's a foregone conclusion that liquid cooling will be in the next generation uh, of high density AI servers from NVIDIA, at least, and so they will drive
yeah.
this. And the industry will have to respond. You and all of your competitors, and the fact that you're there and showing it now, I think is fun, and maybe a little out of character for Solidigm in terms of waiting till something's shipping or right around the corner to start to show things. I think it's fun to show the new technology. So on that front, we wrote about it, as you know, and put up a lot of photos, and we'll link to that in the description of this podcast. So if you guys are curious and want to learn more about it, you can't buy it yet, but you can read more about it, see these drives, and see the demo that Cody and his team put together. But yeah, Cody, I think it's pretty cool. I'm glad they let you out of the thermal lab to chat with us for a little bit, and your perspective is unique, and you're well equipped to talk about this stuff. So I appreciate that. Thank you.
Yeah, and I really appreciate the opportunity. Thank you.